Objective for the experiment is to determine the current amount of iron in the tablets using potassium permanganate solution or known as potassium manganate 7. Second is to analyze iron tablets and to determine the concentration of iron in the tablets. This is introduction. In a redox reaction, both a reduction and oxidation reaction occur. Oxidation reduction processes involve electrons transfer from one species to another. When a species is being reduced, it gains electrons, while when a species is being oxidized, it loses electrons. The oxidation number decreases as when added electrons. Potassium permanganate has been widely used as an oxidizing agent. The presence of excess MnO4- ions act as an indicator in the redox titration because they turn the solution into pink pale color at the endpoint. In acidic solution, potassium permanganate oxidizes iron 2 while it being reduced to manganese 2. So we can see the reaction occurs for the process at the below.
This is about the list of chemical and apparatus. There are three types of chemical reagent, that are iron tablets, potassium permanganate solution, and distilled water. And then for apparatus are 250 ml conical flask, white tile, glass rod, 50 ml beaker, mortar and pestle, dropper, 50 ml measuring cylinder, 25 ml pipette, burette, filter funnel, 250 ml volumetric flask, and retorts tank.
This is the procedure for iron tablet preparation. First, the mortar and pestle was dragged on. Then iron tablets were added and grinded into a fine powder. Then the powdered tablet was transferred to a 50 ml beaker and the mortar was rinsed with distilled water to ensure that none of the iron tablets has been lost. 30 ml of distilled water was added approximately to dissolve the iron tablets. The 250 ml volumetric flask was rinsed with distilled water and the iron tablets were dissolved and transferred to the 250 ml volumetric flask. Make sure that the beaker was rinsed so all the iron tablets were included and the content was poured into the flask. Distilled water was added up to the calibrated mark of the volumetric flask using dropper, stopper, and the flask were shaken to obtain homogeneous solution. Next, for the titration experiment, first the burette was rinsed with distilled water and then potassium permanganate solution. Make sure when you fill in, the top of the burette was below the eye level. The burette was filled with the potassium permanganate solution. Make sure the tap was closed when filling it and there are no air bubbles trapped at the tip. The filter funnel was removed afterwards to ensure the fill level remains constant. The initial burette reading was recorded to 2 decimal places. The pipette was rinsed with distilled water and then the iron solution. The pipette was filled until it half filled. You can do this by holding the down button. The pipette was rotated to ensure the inside was fully rinsed before emptying it into the waste beaker. 25 ml of iron solution was pipetted from part A into a 250 ml conical flask. White tile was placed underneath the flask so that any color changes can be clearly observed. The iron solution was titrated with potassium permanganate solution from the burette. During the titration, the flask was continuously swirled. Upon reaching the end point, a temporary pink solution appeared but faded when the solution was swirled. Continue titrating until a pale pink color persists for more than 30 seconds. That was the end point. The final burette reading was recorded to 2 decimal places. The titration was repeated 3 times.
Next, for the result, the reading must be taken with 2 decimal places. The initial reading must be recorded before the titration. Record the final reading once reached the end point. Calculate the volume titrated by subtracting the final reading with the initial reading. From the information given, we can find the amount of ferrum 2 plus ion in 25 cm³ stock solution, and we can find the molar ratio between ferrum 2 plus ion and manganate ion. From the molar ratio, we can find the amount of manganate ion in the stock solution. Calculation of burette reading. Mean titration of burette is the values we get from the experiment that have less than 0.5 difference. If the experiment gave values that have more than 0.5 difference, the experiment must be organized again until get at least 2 values that have less than 0.5 difference. Then find the average of the values. Next, by using the values obtained from the experiment, first we have to find the amount of manganate ion and then compare the amount of manganate ion with the mole ratio to get the amount of ferrum 2 plus ion. Then find the mass of ferrum 2 plus ion in 25 ml sample by multiplying the molar mass and the number of mole. The values obtained from the calculation is the experimental values. Lastly, compare the experimental values and the theoretical values.
Okay, for this question, we get the value of iron content per tablet is 0.0103 gram, which is smaller than the hypothesis value, which is 14 milligram. This problem occurs maybe from the error. The main source of error is personal judgment with naked eyes of endpoint. It is difficult to control when solution in conical flash changes from colorless to pale pink. We can prevent it by measuring abscesses of solution after each titration. We also can use accurate photospectrometer to get higher absorption value, so higher pink intensity. Second error occurs from transfer of solution. Sometimes some iron tablet still left in apparatus, so it's good if we rinse all the apparatus after transfer the solution. When we shake, we must set the time and must use a clean dry conical flash every new titration. To reading the burette, we can use white paper and place it behind the burette to get the accurate reading. For conclusion, the correct amount of iron in the tablet using potassium permanganate is 0.0103 gram, while the concentration in the tablet is 0.002 molar.
I was hanging with you and then I realized I didn't think it was true. I was surprised when I found out I'd fallen for you.